All right, going over 5.2, some of the problems that I think might be um, problematic. The problems, they're all problematic. Challenging, more challenging than others. Number 11, do algebra first, and then it's really an easy problem. But you've got to do algebra first, otherwise you're kind of spinning your wheels. Let's jump in at number 13. Looks terrible. Let's see what happens. X squared plus 2x plus 3 over x cubed plus 3x squared plus 9x. Right, awful looking problem. Like, what are we supposed to do with that? Except that usually we'll let you be the denominator and hope that things work out for us. A bunch of these problems are straight up rigged problems, and they will work for you if you pick the right u. Amazingly, magic will happen. So 3x squared plus 6x plus 9 dx is du. You're like, well, that's not what we have, but if we look closely, it's almost what we have. If we'd multiply everybody by 3, we'd have it. And then we can just put a 1/3 out front. And so all of that top is du, and all of the bottom is u. And now it's an easy problem because it's 1/3 natural log absolute value of u plus c. So 1/3 natural log absolute value x cubed plus 3x squared plus 9x plus c. So it wasn't too bad once you saw the trick that they were going for there. Number 15. X squared minus 3x plus 2 all over x plus 1 dx. Well, the top is bigger than the bottom, so that's supposed to trigger our brain to think, wait a minute, I need to do long division or synthetic division. We're dividing by x plus 1, then we'll need to divide with -1. Bring down the 1, multiply, add, multiply, add. And remember what this means. We started with x squared. We divided by x, so we're down to an x. So we've got x minus 4 plus 6 over x plus 1. Again, that's just algebra. We have not done calculus yet. So I still need to take the antiderivative of that, but now it's in a much better format for me to do that with. So x squared over 2 minus 4x plus, if I bring the 6 out front, it would be natural log of x plus 1 plus c. If you need to, you let u be x plus 1. Du is just dx, and it's a pretty easy as far as natural logs go. 23, I don't want to do the whole thing. I just want to give you a hint as to what x should be, or excuse me, what u should be. I mean, you'd probably guess this. U needs to be that. 1 minus 3 square root of x. 1 minus 3x to the 1/2, if that looks better. So -3/2, x to the -1/2. -3/2, 1 over the square root of x. So there's u. That's pretty close to du. I need a -3/2 on there to make things work out. -3/2 and -2/3, and then I'm ready to go. So I'll leave that one for you. Again, Cal Chat if you need to see the rest of it. 27. 27's awful. It gives you a hint. It's not really enough of a hint. Let u be the denominator. Okay, well that's probably what you would have picked. because we're kind of used to that. I'm going to rewrite it as 2x to the 1/2 so I can take the derivative a little bit easier. So derivative 1 goes away, so 1/2 2x to the negative 1/2 chain rule times 2. So du, the 2's will cancel out, 1 over square root of 2x dx. So, well, we already said that the bottom was u, and I don't really have anything that's helpful for me here. So this is the only thing I could think of. It ended up working. Let's solve for dx, because I need to replace dx with something. So if I solve for dx, then square root of 2x goes to the other side times du. Now, if you don't like that, you're right to not like that. Like I can't do anything with this yet, right? Because I either have to have everybody in x's or everybody in u's. I can't have this mismatch of x's and u's. So this isn't wrong, but I can't really integrate at this point. But I go back to here, and you may remember it was on the last test when we had to like reverse skate on some of this stuff, the back substitution, however you want to phrase it. The square root of 2x is equal to u minus 1. So now, in place of the square root of 2x, I can put u minus 1. And how they expected you to know to do that, I'm not sure. 1 minus 1 over u du. It should be easy from here. That would be u minus natural log of u plus c. Except I need to replace u. 1 plus square root of 2x minus natural log 1 plus square root of 2x plus c. That's another one where this will never be negative, so I don't need the absolute values. Again, it's not wrong if they're there, but on multiple choice test it would probably be parentheses, since absolute values aren't needed. By the way, omit 43. 43, there's a typo in the book, and I wish I'd have known that before I spun my wheels trying to figure it out. But if you look at CalcChat, they have the right problem. But skip 43. Let's do 45 and 51, and then we'll be done. 45. One of those differential equations. It's been one on each of the last two tests. So it gives us all this information, and we gotta back up and figure out what f of x is. So if I integrate, on this one, if I back up from f double prime, I get f prime. I'm going to rearrange things on this guy so that I can take the integral. So increase the power by 1, divide by the new power, plus c, and then clean that up a little bit. So that would be negative 2 over x plus c. But I know that f prime of 1 is 1, so if I use this piece of information, 1 equals negative 2 over 1 plus c. So c equals 3. Alright, so I'm going to kind of restart the problem here. F prime of x is negative 2 over x plus 3. Some of you guys are leaving that step out. After you find c, you need to include it in the rest of the problem. Now I need to integrate that to get back to f. So f of x equals if I pull the negative 2 out front of that one, it would be natural log of x plus 3x plus different c. So if you want to call it c2, you can, to be clear. It told me this x was greater than 0, so I don't really need the absolute value bars. It's not wrong if you put them in. And now I'll use, I'm running out of colors to use. Let's see if I've got something over here that's different enough to show up. Here's the green information here. F of 1, so they were all 1s, double checking that, yep. So 1 equals negative 2, natural log of 1, plus 3 times 1, plus c. Oh, that didn't show up very well. Natural log of 1 is 0. You all remember that, I hope. C2 is negative 2. So my answer then is negative 2, natural log of x. I'm going to drop the absolute value bars because they said it was positive, so I don't need them on there. It's not wrong if you put them on there. Plus 3x minus 2. So that's solving a differential equation. That means getting f of x and using all the information to figure out exactly what the answer is, what the equation is. The last one I want to look at is 51. Integral from 1 to e. Okay, so a definite integral, so I need to integrate and then put the limits in. 1 plus natural log of x squared over x dx. I think, again, you've got to know your derivative rules well enough that you recognize derivatives so that you can pick u and du correctly. If I let u be 1 plus natural log of x, then du is 1 over x. And then I hope you see how everything kind of falls out, because that's u, that's du. So the integral, oops, these are x values, so I don't want to write those down yet, of u squared du, which I need to change my limits now, u of e and u of 1. We got to remember all our natural log rules. Natural log of e is 1, so 1 plus 1 is 2. So my upper limit is 2. Natural log of 1 is 0. 1 plus 0 is 1. So my lower limit is still 1. And now we've changed this from a really ugly looking natural log stuff to a pretty simple power rule thing. U cubed 1/3. And I'm going to use 1 and 2 because those are u values. I don't have to go back to x stuff because everything is switched to u. So I'm good with this as an answer. I mean, once I plug them in. 2 cubed minus 1 cubed. In fact, that would be an acceptable answer right there, and you could just leave that alone. If you wanted to keep going, 8 minus 1 is 7, over 3 would be 7/3. But this would be a safe stop. That would be a multiple choice answer. This would not be a safe stop because you still got calculus stuff to do. You can't just type that in the calculator, is another way to say it. So get to here and then you're good. If you want to keep going, fine, just don't make any mistakes. Alright, hope you've watched all of them. Hope I see you in person on Tuesday or Wednesday. Who knows what the week will hold. Again, hope you guys are safe, hope you guys are warm, and I do look forward to seeing you in person again soon, hopefully.